Imagine you are building a high-tech bicycle from scratch. If you just slap all the metal, gears, and wires together and try to bomb down a hill immediately, you're probably going to crash. You need to know if the brakes work before you rely on them at high speed. This happens in software, too. If we build the entire application first and test everything together at the very end, the system almost always fails. And when it crashes like this, it is nearly impossible to figure out which specific line of code actually caused the problem. Now watch as the diagram resets. If we take it step by step, checking one isolated piece at a time before connecting them, the process is completely different. If one piece fails, we know exactly where the bug is, and we can fix it immediately. Engineers building software follow this same mechanical logic. They divide the work into layers to make sure every connection is solid before moving to the next. Testing a program is a four-stage journey. It starts with the smallest building block and moves toward the final user. Think back to our bicycle. The smallest piece might be a single pedal. You spin it in your hand to see if it rotates freely, completely separate from the rest of the bike. In software, this isolated part is what we call a unit that looks in code. If building a shopping app, the developer looks only at this isolated box, the login module. They check if the username and password fields work while ignoring other features entirely. Developers perform this unit testing themselves while they write the code. They ensure the foundational building blocks are flawless before the system gets complicated. If two individual pieces of code work perfectly on their own, we still have to check if they will work together. Just like in this video, your pedal might spin perfectly and your gear might be flawless, but when you connect them, the chain might slip. They are failing to work as a team. This animation shows that mechanical disconnect in software. The login module tries to send the user's ID number to the payment module, but the payment module expects a customer ID, so it ignores the message and crashes. Integration testing is designed to catch these teamwork errors. It verifies the interfaces between different modules to ensure they can speak the same language. Once the pieces can communicate, we reach system testing. This is where all the individual modules are finally connected to form the complete application. This is the test of the fully assembled bicycle. You are checking the steering, the brakes, and the pedals as they move together in one machine. Taking a look at this flowchart, we follow the entire customer journey, from logging in and searching to payment and order confirmation. A specialized quality assurance team evaluates the whole system. A scanner sweeps the diagram, verifying the app is secure and optimal. System testing answers the technical question of whether the entire machine works as intended under real conditions. Even a technically perfect system faces one final hurdle. The customer is the final judge of whether the software is actually acceptable. This is the moment the customer takes the bike for a test ride. The gears might work perfectly, but the customer needs to know if the seat is comfortable and if the ride feels smooth on their daily commute. Here we see the software version on a digital clipboard. The customer checks the app against their business requirements. They verify if they can buy things easily and if the financial reports are accurate for their accounting team. This can happen internally before release, called alpha testing, or by giving a test version to thousands of real users, known as beta testing. Acceptance testing verifies if we actually built the tool the customer requested. This timeline shows the complete testing sequence, building downward: unit testing, integration testing, system testing, acceptance testing, and release. Each has a specific owner. Developers build the foundation. Testers check connections. The QA team tests the whole system, and the customer gives final approval. This sequence explains a common interview question: why must unit testing happen before system testing? Fixing a tiny, isolated code bug early is simple and inexpensive. But if you wait until the very end, untangling an error within fully integrated software is a massive and costly task. Now that we know who tests the software and when they do it, we have to look at how they choose what to test. To test a password box like this, you can't just type random characters and hope you find a bug. You need a scientific approach. In our next lesson, we'll see how testers use black box and white box testing to find those hidden errors.